Okay, cycloalkane. So it is still under the alkane functional group, but now the structure of the carbons are formed in a cyclic form, or is what they call as a ring. Okay, it is no longer in an open chain. So they are also known as alicyclic compounds. Okay, the properties are very similar to aliphatic alkanes. So the chemical properties like being inert and so on still remain. So the prefix that is used in terms of naming can be ali is added, or most of the common way of naming is by adding the word cyclo as well. So the general formula will be CnH2n. So unlike alkane, the general formula is CnH2n plus 2. So in cycloalkane, there is no plus 2. It will be CnH2n. Later you will see this is actually similar to alkene. Okay, alkene is also having general formula of CnH2n. So here some example. We have when there are 4 carbons. So as in normal alkene, it will be known as butane. So you just add the word cyclo in front. So 5 carbon, 6 carbon, so cyclopentane, cyclohexane. This is when you have other functional group. In this case, this is a carbonyl in ketone. So it will be called, instead of cyclopentane, cyclopentanone. And then this is butyl cyclohexane. So in which that you have cyclohexane over here, and you have 1, 2, 3, 4 carbon, which is the butyl as the substituents. Okay, so butyl cyclohexane or N-butyl cyclohexane, and this one is also known as trans decalin, and other example is basically you have 2 cyclohexane fused together. Okay, fused together. So the IUPAC nomenclature for cycloalkane. So basically you're just going to add the word cyclo in front of the normal alkyl name, and the simplest example for cycloalkane will be containing 3 carbon, which is cyclopropane. So that is the simplest form of cycloalkane. You cannot have 2 carbon, because if it is 2 carbon, that will just be a normal straight chain. Okay, it cannot form cyclic. So you cannot form cyclic with just 2 carbon. So you have cyclopropane, cyclobutane, cyclopentane, hexane, heptane, and so on. So depending on the number of carbon present, and the substituents can be attached at any of these carbon. So let's say you have cyclobutane, so it can be at carbon number 1, number 2, number 3, or number 4. And the place where you have a substituents, that will be considered as carbon number 1. Okay, that will be considered as carbon number 1. So here you have substituted cycloalkane. So they are named similar to that when you name a branch alkane. So example, you have cyclopentane as the longest parent chain. So when you have a methyl group, so it will straight away be called as methyl cyclopentane. Okay, this one, you have ethyl group attached to a cyclohexane, so ethyl cyclohexane. So when there is only one substituent present, you don't have to mention the position or the numbering position, because it will be assumed that where the substituent is located will be carbon number 1. Okay, so this will be carbon number 1, this will be carbon number 1, and number 2 will depends on whether you follow clockwise or anti-clockwise position. But if you have more than one substituent present, okay, in the cycloalkane structure, so you have to see the priority of the substituents itself. So example, in this case, you have cyclohexane, in which you have methyl, okay, and also an ethyl group. So among these two, ethyl will have higher priorities. So you have to consider this carbon as carbon number 1. Okay, and then instead of going number 2 over here, so if you give this carbon as position number 2, this will be 3, 4, 5, and 6. So the methyl end up being at C6. So that is like a higher number compared if you go anti-clockwise. So if you go anti-clockwise, the methyl group will be at position carbon number 2. So 1, 2, 3, 4, 5, 6. So the name will be written as 1-ethyl 2-methyl cyclohexane. Okay. Then take note that when you have the cyclic or the cycloalkane, okay, and you also have an open chain, make sure that the longest parent chain will be the end name, like hexane or cyclohexane. So for example, like this one, you have cyclopropane, but it is attached to this 10 carbon chain. So this definitely cannot be the parent name. Okay, the parent name like this. So the 10 carbon chain will be the parent name, while this cyclic or cyclopropane will be the substituent. So when it becomes substituents, the name will still change. Instead of A and E, you are going to replace it with YL. So from cyclopropane, this will be cyclopropyl. Okay, so let's say you have a cyclopentane attached to this 10 carbon, so it will be called as cyclopentyl. Okay, and the position of the carbon is also noted when you write the name. Then to the second functional group, which is alkenes. So this is an example of unsaturated hydrocarbon, okay, or unsaturated organic compound. So there is a C double bond C present in the molecule. So at least there should be one C double bond C, okay, and the general formula would be CnH2n. So this is actually similar to cycloalkane. So meaning that when you are given a chemical formula, so they could be an isomer, meaning same number of carbon and hydrogen but different in a way the carbon and hydrogen are being arranged. So it contains two hydrogen less than alkane and considered to be as unsaturated. So it can also be acyclic and also cyclic. So like uh, alkane earlier, it can be in open chain or it can also be in cyclic form. So example, the open chain structures like this one, which is ethylene or propylene, or the IUPAC name ethene or propene, while cyclic, so you can have cyclopentene, cyclohexene, cyclooctene. So this means that the structure is actually similar to what you have in cycloalkane, but it contains one C double bond C in the structure. Then it can also be divided into symmetrical and unsymmetrical alkene. Okay, so in symmetrical, you have the same number of hydrogen atoms on both sides of the C double bond C. So when you draw the structure or you see the chemical structure of that alkene, and you see that there is what you call plane of symmetry like this in the middle. So on this side it is the same. You have CH3, you have hydrogen. On this side also you have CH3 and hydrogen. So this is considered to be symmetrical. And for unsymmetrical, so it will be something like this, in which that for this carbon you have two hydrogen, for this carbon you have hydrogen and a CH2, CH3. Okay. Later when we go into the topic of isomerism, okay, there is a specific type of isomerism for alkene, which is the cis-trans and ENZ system. That way, we will see easier on whether the alkene is symmetrical or not. But when you draw it flat like this in an open chain, so just check on both sides whether it contain the same number of carbon and hydrogen as the right. Okay, so this is also considered to be unsymmetrical because this side, okay, for this one is different compared to on this side. Same as well for this C double bond C. So the IUPAC nomenclature. The common name. So alkene also have common name. Uh, the normal alkene, which is from ethane, will be converted into the suffix of YLENE, which is ethane to ethylene, okay, or propane to propylene. But this is a common name, not following the IUPAC. Whereas in IUPAC, you are just going to replace the A and E with E and E. Okay, A and E with E and E. So from ethane, it will go into this ethene, and propane into propene. So the IUPAC naming is easier than the common name. So always, how to say, refer, if let's say in exam, check on the question whether it specifies for you to write IUPAC or not. If the question doesn't specify for you to write IUPAC, then common name may be acceptable. But if it specifies for you to give IUPAC name, then always go for this one. So the rules for naming alkene, okay, like in alkene, always find the longest carbon, but the longest carbon must include the double bond. Okay, it must include the double bond. So for example, over here, this is pentene, not hexene. So what does it mean by? So you have 1, 2, 3, 4, 5. So this is pentene, so not hexene. And then the second, this one, it would be 1, 2, 3, and then you have another 4 over here, which is 7, and then 8. Okay, instead of going this way. So if you go this way, 1, 2, 3, 4, and then add another 4, that will be 8 plus 1, that will be 9. So octene instead of nonene, so this would be 8. So you have to include the C double bond C. Okay, unlike alkene you must always go and select the longest chain that is possible. But in alkene, naming alkene, you must select the longest chain, but the longest chain must include the C double bond C. Okay, and this one, so this C double bond C is in the middle. So this one you can start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is decene. Then the second rule state that you must identify the position of the C double bond C. Okay, you have to tell where does the C double bond C is located. So if it is at carbon number 1, okay, so it will be written as 1 dash and the name of the alkene. So like for example, this has 4 carbon, so this is butene, and the position of C double bond C will be at carbon number 1. Okay, always start numbering from this side. So you cannot start numbering from here. If you start numbering from here, it will give 1, 2, 3. So the C double bond C will be at carbon number 3. Okay, so we try to give the lowest possible numbers, okay, if possible. So 1 butene, not 3 butene. And this one, this looks like a symmetrical. So it's symmetrical. If you start from the left or from the right, the same numbers will be applied to the C double bond C. So this will be 2 butene. And the third example, it will be called as 2-pentene, not 3. So you start from here, 1, 2, 3, 4, 5. So you cannot start numbering from this side. So this would be 1, 2, 3. Okay, so we try to give the lowest possible number. And when it comes to cyclohexene, so this would be considered as carbon number 1, because if you start from this side also, this will be carbon number 1. Okay, 1, 2, 3, 4, 5, 6. Okay, so in cyclic, if there is no other higher priority substituents, so this double bond will always be at carbon number 1 and carbon number 2. And then check for any substituents. So the position will be noted as usual. So the first example, when you have an alkyl group present. So when alkyl group is present, so the lowest possible, the lowest numbering will be given to the alkene. So you have 1 starting from this C double bond C. So 1, 2, 3. So the methyl group is at the third position. So and the way you write will be by writing the name of the substituent first, because this is not considered to be substituent. So substituents goes in front. This will be going into the parent name. Okay. So 3-methyl dash, then the number of the position for the alkene, 1 dash, and then number of carbon. In total, there are 5 carbons. So this would be pentene. Okay. And then in cyclic, okay, in cyclic form, so earlier you have this cyclohexene, okay, cyclohexene. But when you have a substituents, so always give the double bond, okay, the lowest numbers if the substituents has lower priority. And then after you've done that, try to give the lowest possible number to the substituents as well. So the numbering should go 1, 2, 3, okay, instead of going clockwise. So if you go clockwise, the number would be 1, 2, 3, 4, 5, 6. So this would be at the last carbon. Okay, you can give these 3. So why you want to give the number position at carbon number 6? So 3-methyl cyclohexene, okay, instead of 6-methyl cyclohexene. Then for this one, okay, for this, you have substituents and also the C double bond C. So this looks to be symmetrical as well. So if you start from here, the numbering will be 1, 2, 3 will be carbon number 3. If you start from this side also, it will be 1, 2, 3. So either way, the double bond will be at position carbon number 3. But then you have to look for the substituents. So you have to give the lowest possible number to the substituents as well. So instead of starting the numbering from this side, which is 1, 2, 3, 4, 5. So why not start from here? So you, because the C double bond C will still be the same, which is carbon number 3. So 1, 2, 3, 4, 5, 6. So it will be written as 2-methyl dash 3 hexene. Okay, not 5-methyl 3 hexene. So let's try look at this example, 2 example. So we have this alkene with how many carbon? You have 1, 2, 3, 4, and 5. So this would be pentene. And this is being terminal carbon. So it will be at the first position. So it will be 1-pentene. And this CH3 is at carbon number 3. So 1, 2, 3. So this will be 3-methylpentene. And this one, okay, you see that the C double bond C is on the first and second carbon. So this you have to find the longest chain, but it must include these 2 carbon as well. So 1, 2, 3, 4, 5, 6. So there are 6 carbon if you follow this path. But if you go straight, you have 1, 2, 3. So this has 4 carbon. 3 plus 4, 7, plus another 1, 8. So 8 carbon in total if you go this way. So 8, that will be octene, and the C double bond C at carbon number 1. So this will be 1 octene, and you have a substituent which is this green color alkyl group. So 3 carbon from propane to propyl. So at the third carbon, so 3 propyl, 1 octene. Okay, 3 propyl, 1 octene. And what if the compound, or for that alkane, when it has more than one double bond? So it has 2 double bond in the same structure. So that alkene will be called as diene. Okay, will be called as diene. So here an example. So instead of being just a normal butene, so this compound contain 2 double bond. So you have one here and another one on the third carbon. So one on the first carbon, and the second C double bond C on carbon number 3 and carbon number 4. So when you have more than one, you just have to add the prefix di, tri, tetra on before the word ene. Okay, so normally you will be writing as butene, but when it has 2 double bond, it will be written as butadiene. Okay, diene. So you have to include the word diene. If there are 3, that will be triene. Okay, so but for this example, which is diene, so the position also we have to be included in the name. So this, for example, is written as 1,3. So 1,3 meaning that it is at position carbon number 1 and carbon number 3. So carbon number 1 and carbon number 3. And then the second example, so you have 1, 2, 3, 4, 5, 6, 6 carbon. Okay, 6 carbon with 2 double bond. So that definitely will have the name of, instead of hexene, it will give hexadiene. And then you look at the position of the C double bond C. Okay, the C double bond C is positioned at carbon number 2. Okay, 1, 2, 3, 4. So 2, 4 hexadiene. If you start from this side, it will be at carbon number 1, 2, 3, 4. Same as well. So these are symmetrical. So this diene, okay, can be further divided into several types, which is conjugated, which is this one. So conjugated meaning you have the double bond separated by a single bond. So you have double bond, single bond, double bond, and then another single bond probably. So but it must be separated by a single bond. And then you have isolated diene. So both of these double bond are being separated by more than one single bond. So you have double bond, single bond, single bond, double bond. So it could be double bond and then a few single bond present, and then only you found again the double bond. And you also have this third example, which is cumulated diene. Okay, another types of diene which is cumulated, in which you have the C double bond C side by side. Okay, you have double bond and then another double bond. So 3 types, which is isolated, conjugated, and cumulated. These 2 examples are considered to be conjugated because you have double bond, single bond, double bond. This one also you have double bond, single bond, and double bond. So let's try with this compound, giving the IUPAC name for the following. So there are 3 cycloalkane and 2 alkene over here. So the first example, here we have how many carbon? You have 1, 2, 3, 4, 5, 6. So 6 carbon in cyclic form, and you see that there is no double bond whatsoever. So this is definitely an alkene or cycloalkane. So 6 being hexane in a cyclic form, this will be called as cyclohexane. And you see that there are 2 substituents present. You have methyl group and you have ethyl group. So ethyl will have higher priorities compared to methyl. So this will be considered as a carbon number 1. So 1, 2, 3. So the name of the compound would be 1-ethyl 3-methyl cyclohexane. Okay, so this will be considered to be as carbon number 1, and this would be carbon number 2. Then the second one, over here we have 5 carbon, 1, 2, 3, 4, 5. So this would be cyclopentane. Okay, cyclopentane with 2 substituents. You have methyl over here, and this one is isopropyl. Okay, you have 1, 2, 3, but in this shape, so this would be isopropyl. Or instead of using isopropyl, you can also use the name of methyl ethyl, but that should be written in bracket. Okay, so instead of this between these two substituents, this will have higher priority compared to methyl. So this will be considered as carbon number 1, carbon number 2, carbon number 3. So the name can be written as 1 isopropyl 3 methyl cyclopentane, or you can also write as 1 methyl 1 in bracket methyl ethyl close bracket dash 3 methyl cyclopentane. Okay, and the third over here, this is cyclopropane, 3 carbon, 1, 2, 3 with 2 methyl group. So you have methyl 1, methyl 2, and this is considered to be the same. I mean, if you start from here, this will be carbon number 1, this will be carbon number 2, or if you start from this side also, carbon number 1 or carbon number 2. So the name should be written as 1,2-dimethyl cyclopropane. Okay, so 1,2-dimethyl because there are two this methyl group present or attached on the cyclopropane. And for this alkene example, okay, alkene example, find the longest chain that includes the C double bond C. So you have 1, 2, 3, 4, or you can also go from here 1, 2, 3, 4, which is exactly the same. So when you have 4, okay, so from butane, you have to change the name into butene. Okay, butene, and the position of the C double bond C is at carbon number 2. Okay, carbon number 2. So that will be 2 butene, and then you have one substituent, which is methyl group at carbon number 2 as well. So 2 methyl 2 butene. Okay, 2 methyl 2 butene. And this second alkene example, okay, find the longest chain as well that includes the C double bond C. So you have 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. You start from this, also will give you 5 as well. So 5 carbon, that will be pentene, and the C double bond C at carbon number 2, so 2 pentene. And if you look, there are 2 methyl group, CH3 and CH3, so dimethyl, but that will be at position carbon number 2 and carbon number 4. Okay, so the name will be 2, 4 dash dimethyl dash 2 pentene. Okay. And the third functional group, which is alkyne. So alkyne consists of a triple bond. Okay, you have C triple bond C, is this one. So it means that between these 2 carbon, there is 1 sigma bond and 2 pi bond. So the p orbital are overlapping between 2 p orbital overlap, okay, between these 2 carbon. The general formula is CnH2n minus 2. Okay, CnH2n minus 2. So unlike alkene is CnH2n plus 2, but alkene CnH2n. So but for alkyne you have to minus 2. Okay, so the alkyne triple bond, which is this one. So this is actually hybridized. Okay, sp hybridized. In alkene, it is sp3, while in alkene, sp2. So this is sp hybridized, in which that the s orbital, okay, one s orbital and one p orbital from the carbon is hybridized with this hydrogen, and this p orbital also forming hybridization with another carbon over here. So the other two p orbitals, okay, which are left, so this form the overlapping, okay, overlapping with the other next carbon. Okay, so this can be explained using the valence number of valence electron. Okay, like this. So the nomenclature for alkyne, so basically you just replace the suffix which is at the end with y and e. Okay, y and e. Y and e at the end. So for example, when you have butane, it will be converted into butyne. Okay, from butane to butyne. So compounds containing both double and triple bonds are called as E9. So En actually comes from the alkene E and E, right? And then it is combined with Y and E. And when you have double and triple bond together in the same molecule or in the same compound, you give the lowest possible number to the first multiple bond. Okay, but if there is a choice, then alkene takes priority. Okay, what does it mean here? Try to give the lowest possible number to the first multiple bond that you can select. But then again, if you can choose, try to give alkene lowest priority. For example, this one only have one C triple bond C, so definitely the name will be called as 1-butyne. But here the second example, it contains 2 double bond and also 1 triple bond. So this double bond can be considered at the first carbon. So you have 1, 2, 3, 4, 5, and then 6. But if you start from here also, the alkyne can also be given the position at carbon number 1. So 1, 2, 3, 4, 5, 6. But here when it is said, alkene takes priority if you have a choice. So you have to choose this what you call that, C double bond C as position carbon number 1. So 1, 2, 3, 4, 5, and 6. So the alkyne, okay, even though the name is still in the parent name, but it will be considered at position carbon number 5. So over here, the name will be written as 1,3-hexadiene, okay, which correspond to the position of the diene itself. 1 and also carbon number 3, carbon number 1, and carbon number 3. And then you have to dash 5. So this 5 actually denotes the position of the C triple bond C. Then only you can dash Y and E. Okay. So 1,3-hexadiene, the 1 and 3 correspond to the position of the double bond. Okay, these two, carbon number 1 and then carbon number 3. And this carbon number 5 will be written at the back before the Y and E. Okay, so 1,3-hexadiene-5 dash Y and E, or ine. We call it something like that. Okay. So this will be selected instead of this C triple bond C being positioned at carbon number 1. Okay, other example, you have ethyne Okay, 1 butane, 2 pentane, 4 methyl 2 hexane. So the blue color is the IUPAC name, while the red color is the common name. So common name is sometimes mostly you can find in chemical being sold. Okay, when you want to purchase chemical, the name may not be given in the IUPAC name, so it may be given in this other common name. Okay, so these two other example here includes halogen. Okay, these two includes chlorine and bromine. Okay, includes chlorine and bromine. We haven't gone into alkyl halide yet, but then again, you see that the numbering starts from this side 1, 2, 3, 4. Okay, instead from here 1, 2, 3, 4. So if you start from this side, then the bromine and chlorine will end up with position 6 and 7. Okay, so we can give them lower number. So start from here because the C11C will end up being the same. Either way, you start from this side or this side, it will still be at carbon number 4. Okay, so 1, 2, 3, 4 instead of from this side. So the name is written as 3-bromo 2-chloro, not 2-chloro 3-bromo, because still you have to follow the alphabetical order. Okay, B first and then C. So 3-bromo 2-chloro 4-octane. Okay, this example, second example, the name is given as 1-bromo 5-methyl 3-hexane. Okay, if you look over here, the numbering start from this side 1, 2, 3, but you can also start from here 1, 2, 3. So still the same, but then again between bromine and this metal group, okay, so bromine will have, or halogen will have high priority, so it will be selected at carbon number 1 instead of from here. This will be 1, 2, 3, 4, 5, and 6. Okay, so 1-bromo 5-methyl 3-hexane. Again, B first, then M, according to the alphabetical order. So these are what you call the summary of the first three functional group, which is alkane, alkenes, and alkynes. So here the spelling is using I, but normally we use Y, but I is also, I think this one is the old spelling. I haven't changed this. Then again, the IUPAC has started using the spelling with Y. Okay, so alkene, alkene and alkyne with their general formula. This one being CnH2n plus 2, alkene CnH2n. This is exactly the same as cycloalkane. Okay, cycloalkane. And then alkyne CnH2n minus 2. Okay, so you have the if you look, only alkene has the first what you call compound, which is methane. So for alkene, you cannot have methane because alkene must contain C double bond C. So this one, it only contain like one carbon. So there is no, it is impossible for it to form C double bond C. Same as well for alkyne. Okay, you cannot form C double bond C when there is only one carbon present. So the alkene and alkyne starts its homolog series with 2 carbon. Okay, 2 carbon, 2 carbon. Then on to alkyl halide or haloalkane. So this, when you have a halogen present, okay, in the normal functional group, either being alkene, alkene, or alkyne. Okay, you see that there is a halogen. Okay, this halogen can be chlorine, fluorine, bromine, iodine. So these alkyl halide are classified as either primary, secondary, and tertiary. So this actually the same concept as how to determine whether the carbon is primary, secondary, or tertiary. Depend on whether the halogen atom is attached to primary, secondary, or tertiary carbon. So basically, you have to check the carbon that contain this halogen. So if that carbon is secondary, then you consider the alkyl halide to be secondary as well. If the carbon is primary, then the alkyl halide will be primary as well. Okay, so here example, if there is only one carbon, okay, this carbon tetrachloride CCl4, okay, chloroform CHCl3, and then dichloromethane, which is this one CH2Cl2, are normally used as solvent, okay, in chemical reaction or in organic reaction. And this chloroform, dichloromethane, and CCl4 also is used quite widely as solvent in inorganic uh, reaction as well, okay, in order to dissolve metal salts. And then other example like bromochloro-difluoromethane, which is this one, mainly used in fire extinguishers, okay, fire extinguishers, and also the refrigerant, okay, in your refrigerator is using this CCl2F2 or dichlorofluoromethane, okay. So these are mainly used in, I think in our car also, they use this CCl2F2. And we have this polyhalogenated hydrocarbon, very reactive, and they have been used as residual insecticides, okay, to kill bugs. But then again, they are major contributor to pollution. Okay, example like what we call here DDT. Okay, this is the structures of 1,1-trichloro 2,2-bis p-chlorophenylethane. Okay, so it has substituents over here, and then you have another 3 chlorine over here. So then we go on to the naming. Okay, nomenclature of this alkyl halide. Okay, first step, always choose the longest carbon chain, okay, as the parent name. It can be alkane, alkenes, or alkyne. Okay, the first three that we have seen earlier. Okay, then only you see the longest carbon chain must contain this functional group of halogen as well. So this halogen will try to give them the lowest possible numbers. Okay, and the name, instead of being called fluorine, iodine, bromine, and chlorine, it will be known as fluoro, chloro, bromo, and iodo. Okay, remember, it won't be written as fluorine anymore, or chlorine, or bromine, or iodine. So example, if you look on the first one, this is normal alkane. Okay, normal alkane. There is no double bond, no triple bond. So start numbering by trying to give the lowest possible number to the substituents. So you have 1, 2, 3, 4, 5, 6, and 7. So the bromine will get to be at position carbon number 2. So if you start from here, it will be 1, 2, 3, 3, 4. So the first substituents will come in at carbon number 3. So choose from this side. So the name will be, there are 7 carbon, so that will be heptane. This bromine will be called as bromo, carbon number 2. So 2 bromo, and then you have 2 methyl group dash 4,5 dimethylheptane. Okay, so B will be written first according to alphabetical order compared to M. So bromo, then only methyl. And then this one, 6 carbon, okay, hexane. But if you start numbering from this side, it will give you 1, 2, 3, 4, 5. So this methyl can be at position carbon number 2 as well. But between bromine and methyl, so bromine or halogen group have higher priority. So that's why you have 2 bromo 5 methyl hexane instead of 5 bromo 2 methyl hexane. Okay, and this is with what you call alkene. Okay, so alkene, choose the longest chain, okay, with the alkene itself. So 1, 2, 3, 4, 5, and 6. Okay, 1, 2, 3, 4, 5, and 6 instead of from this side. So if you start from here, 1, 2, 3, 4, so the C11C will be at carbon number 4. Okay, so from this side it will be at carbon number 2. So 1, 2, 3, 4, 5, 6. Okay, so don't look at this 2E and transfers, that is under isomerism, which is in chapter 6, chapter 3. But the name, okay, will be written as 6 bromo because B first, and then 4 chloro, okay, BC, 4 chloro, and then 5 methyl, 5 methyl, hex 2 in, hex 2 in. So when there are too many, how to say, substituents that is already being present, so the numbering of the alkene can be written in front like 6 bromo, 4 chloro, 5 methyl, 2 hexene, or instead you can put the number or the position of the C double bond C at the back, but before the E and E, like this example. Okay, like the one in alkyne just now. So that is on alkyl halide. Now on to the alcohols group. So alcohols are compound that contain hydroxy group, which is OH. Okay, OH group attached to the main carbon chain. So the general formula is normally written as ROH. So R can be the simplest from CH3OH or methanol, or it can be more complex type of alkyl. So it can be in open chain, or it can be cyclic as well. And there could be double bond or triple bond or other types of substituents like halogen, aromatic ring, and additional hydroxyl groups present. So example, this is the simplest form of alcohol, which is only having one carbon and one OH group. So this will be called as methyl alcohol, or according to IUPAC, methanol. So it can be written this way, or in simplified version or simplified form, CH3OH. So you have to write CH3 first, then only you write the OH. If there are two carbons present, like this, CH3, CH2OH. So this side, CH3, CH2OH. Okay, so this would be ethanol. So alcohol can be classified as either being aliphatic or aromatic. So aliphatic is all the example like open chain alcohol, ethanol, methanol, propanol, so on. While aromatic, it involves benzene ring. Okay, benzene ring having the OH group, okay, which have a specific name in what we call as phenol. So this later the name will be under the aromatic part. So so aromatic alcohols can be further classified into a few of these classes. First depends on the number of OH present. So that could be the least is one OH group, but they can also have two OH. So two OH meaning instead of alcohol that will be called as diol, and then three OH that will be triol, and then type of the carbon atom to the hydroxyl group is attached. And then the presence or absence of unsaturation on the carbon chain. So whether it contain double or triple bond on the compound. So this is it listed in a flow diagram. So number based on number of OH group. So when it contain only one OH in what we call as monohydrate alcohol, two OH group dihydrate, and then three OH group trihydrate alcohol, and polyhydrate meaning more than three. So that could be 4, 5. Example here is mannitol. And then we can also classify it based on the carbon type of carbon atom, which is primary, secondary, and tertiary. So primary alcohol meaning that the OH group is attached to a primary carbon. Secondary, the OH is attached to secondary carbon, and tertiary, the OH is attached to the tertiary carbon. Then for presence of unsaturation, this is all saturated, meaning all C double bond C, all single bond, no double bond can be found in the compound, while unsaturated meaning that there is at least one C double bond C in the structure of the compound. Okay, so yeah, this is the end for part 1. Okay, before I proceed to the second part, so do you have any question?